In this video, you will learn acid-base reaction. So let's start with what is acid and what is base. An acid is an ionic compound that when it dissolves in water, it forms H+ cation. When it dissolves in water and forms this cation, this hydrogen ion will combine with the water molecule and form H3O+. And this H3O+ is called hydronium ion. So in other words, whichever the ionic compound dissolves in water and produces H+, that will be considered as an acid. For example, over here, HCl is an acid because when it dissolves in water, it's going to produce H+ and also Cl-. That's why it is an acid. I use the word ionic compound. What happens if a compound that's not ionic, that means when it dissolves in water and doesn't provide any H+, for example, a sugar molecule, C6H12O6. When this molecule dissolves in water, it doesn't give us any H+, and therefore is not an acid. So how do we know which one is a strong acid and which one is a weak acid? A strong acid will, first of all, dissolve in water, and secondly, it will completely dissociate. That means it will separate into everything into its cation and anion. In this case, when we have HCl, when it dissolves in water, everything will become like this. They don't combine as a solid anymore. So how do we actually determine which one is a strong acid? Well, for this semester, we were lucky. There are only 6 strong acids that we need to be aware of, namely hydrobromic acid, HBr, hydrochloric acid, HCl, hydroiodic acid, HI, nitric acid, HNO3, perchloric acid, HClO4, and sulfuric acid, H2SO4. Personally, I have played with 5 of them. For example, sulfuric acid over here, they use it for the car battery. So inside the battery, for the conventional car, not the electrical car that you see in the market now, but the conventional one. So they use sulfuric acid to make the battery. Nitric acid, they use it to dissolve whatever dirt on a jewelry. Okay, and the other ones, hydrochloric acid is the most common acid that we use in the lab. So what is a weak acid? Any acid that is not a strong acid will be considered as a weak acid. Okay, so by definition, that means only partially react with water and form H+. So at least we know that it's an acid, but it's not completely dissociate. For example, only certain percentage will dissociate, not 100%. So that will be considered as a weak acid. Well, the easier way is, for this semester, anything that is not a strong acid will be considered as a weak acid. For example, acetic acid, would that be a strong acid or weak acid? It would be a weak acid. Why? Because it's not in this list. So only the 6 acids from this list for this semester will be considered as strong acid. In this case, acetic acid, that is a weak acid, only about 1% of the acetic acid molecules are presented in water when we dissolve it. You can see the double arrow over here. The use of a double arrow in the equation denotes the partial reaction aspect of this process. That means not 100% will go to the right. and it also means it can be reversible. That means this side, the side on the right, can also be a reactant and yield the opposite direction. Here are the common acids that we may see in our daily life. For example, orange juice, lemon juice, grapefruit juice, those containing citric acid, and vinegar that we use to make salad and vegetable, that is acetic acid. Now we know what an acid is, so what about the base? A base is a substance that will dissolve in water to yield hydroxide ions. What is a hydroxide ion? Over here, OH, always come together, OH negative. This is a hydroxide ion. So a base, how do we know whether that molecule is a base? First of all, it must be an ionic compound. That means it must be able to dissolve in water and dissociate. That means it will give us OH minus anion. The common one will be the elements from the first group and combined with the OH. So that is a common one, and it will be completely dissolved in water and dissociate in water. In this case, sodium hydroxide, when it dissolves in water, it will form sodium cation and hydroxide anion. All right, so these groups will be considered as a strong base. A strong base is when this ionic compound dissolves in water, it will be completely dissolved and completely dissociate. Over here, it shows again how a base can dissolve water and form ions. So what is a weak base? A weak base, usually it's not 100% dissociate. Or from the formula, well, it must be an ionic compound. In the formula, sometimes you don't see the OH. For example, in this one, ammonia, you don't see the OH in the formula, but when it's dissolved in water, it will take the H from the water and forms OH minus. Okay, so when it dissolves in water, it forms OH, that means it's a base. Let me give you another example. Over here, let's say sodium acetate or sodium citrate. Okay, let's say sodium acetate is CH3COO. Okay, so sodium acetate, when it dissolves in water, is going to produce CH3CO2 plus OH minus. Okay, so it produces the hydroxide and therefore it is a base. And ammonia is an example of the base that we use while we live in the city, so we don't see the farm too much. But ammonia is the old way of using it as a fertilizer in the farm. Okay. Now, I would like to talk about how do we know what is strong, and whether strong does it mean that it is, let's say, if I have a strong acid and I have a weak acid. Let's start with a new page. Okay. Here, I have a beaker over here. And inside the beaker, let's say I have the same amount of water. I'm going to put a strong acid into the left beaker, strong acid. And on the right one, I'm going to put a weak acid in it. Okay. Before I give you more information, let me ask you this one. Do you think the acid on the left will be more acidic than the acid on the right? You may say yes, because I'm putting a strong acid in it. But in reality, it is not necessary. Why? Let me put it this way. We know that hydrochloric acid is a strong acid. And let's say we know that hydrofluoric acid is not a strong acid, it's a weak acid. Okay, so if you put 3 drops of the hydrochloric acid to the left beaker, and let's say we put 100 drops of the weak acid here, and by the way, let's say is completely dissolved and dissociate. So now, which one is more acidic? Of course, the one on the right will be more acidic. Why? Because it has more H plus in it. And this one determines how acidic it is. Okay, over here you only put 3 drops, so you don't have the concentration as the one on the right side. And in this case, HF, if we dissolve a lot of quantity in water, it will be more acidic. All right, let's talk about the acid-base reaction. It is, in this case, is also called neutralization reaction. What do I mean by that? When an acid reacts with a base, what will we form? We'll form salt and water. What do I mean by that? Let's put an example over here. Whatever acid it comes, you always have the form of producing H plus. Whenever a base it comes, it always comes with OH minus. When an acid sees a base, these 2 pieces will combine together. What do we get here? H plus, OH minus. I have a positive, I have a negative. When they combine together, I get a water molecule. Okay? So, when an acid reacts with a base, we should expect to yield a water molecule that is over here. Another product is a salt. Let's look at the following example and let's see what a salt is. Over here, we have magnesium hydroxide reacting with hydrochloric acid. So hydrochloric acid, when it dissolves in water, the acid will form like this, H plus and the anion. Over here, the base, when it dissolves in water, we get Mg cation and we get OH anion. We know that these 2 is going to combine and gives us water. What about the rest? What about this part, Mg and Cl? Okay, so let me put it this way. Mg and Cl, they will be in water. And we call this combination a salt. So a salt, it is an ionic compound and it's soluble in water. Let's look at this again. Just remember, an acid-base reaction, it is a combination of an acid and a base, and it's going to yield a salt and water. Okay, so let's look at some examples. All right, let's look at problem number 1. When magnesium hydroxide reacts with sulfuric acid, what are the products? Over here, we can see this is a base. Why? Because this one is from group number 2, and when it dissolves in water, it forms OH, so we know it is a base. How about this? This is strong acid. It's one of the 6 strong acids on the list. So when this dissolves, we have H plus, and we also have SO4 minus. So when this dissolves, these 2 is going to combine and forms water molecule. And also, Mg combines with this, it will be soluble, and it forms MgSO4. It's soluble. Okay, and therefore B is your answer. Okay, which of the following, number 2 now, is a strong acid? Well, of course, so number A over here will be the answer. And number 3, which of the following is a strong acid? Well, again, if it's one of the 6 strong acids, then it will be a strong acid. In this case, it will be HBr. All right, so I think you can do the rest if you follow the previous lecture that we just had.